Ionic and covalent or molecular bonds. Ionic is going to have a meaning to itself, and then covalent and molecular, they mean the same thing. An ionic bond means that you are bonding a metal and a non-metal. Okay, so all you have to do is, if you're being given two elements and they're bonding, you just have to identify if one's metal and one's a non-metal, and if it is, then it's a ionic bond. Metals always tend to be on the left, non-metals always tend to be on the right, and you're always going to keep the more positive object to the left. So if we were going to pull out some ionic bonds, let's go with something like calcium, and anything from the non-metal side, how about arsenic? AS. Arsenic is 33 and calcium is 20. So we look them up. You find out that calcium is 2 plus. Oops, you don't need anything there. Calcium's 2 plus and arsenic is, where's arsenic? Arsenic is 3 minus. They crisscross to be calcium 3, arsenic 2. So the crisscross is the same. The only thing you might have to do is identify this thing as ionic. Okay, metal, non-metal. You could get something like maybe where we use a stock number. So you'd have to use your ion sheet, and let's see. So anything from the middle here, your transition metals, you're going to have a more difficult time of figuring out what the ionic number is. So let's try to take something odd. Let's go with silver. Let's see if silver's on here. Ah, silver's right there. I don't want to use silver. Let's pick something else. Let's go with osmium. Nah, I don't want to go with osmium. Well, point I'm trying to make, without flipping this page over 50 times, is that anything that I have listed on my ion sheet, if I'm talking about mercury or copper, nickel or whatever, the vertical column concept works the same. So if you're using copper, and everything in its vertical column is going to be that same charge. If you're using something from this column, you just find something in that vertical column and you use its stock number charge. So let's do a stock number here. Let's go with iron 3 and selenium. Okay, so you'd know that iron is Fe. It's 3 plus just because of the fact that it's a stock number, 3 plus. Selenium you'd have to look up. I don't know what that is offhand. When I look it up, it ends up being Se 2 minus. They crisscross and you're left with Fe2 Se3. Metal, non-metal, so it's ionic. What people like to do that makes this wrong is they like to somehow go Fe2 and then they like to stuff in the stock number. Okay, if you do this, it's totally wrong. Not even part marks, so don't do that. Ionic bond, metal and non-metal. Your covalent or molecular bond is going to be a non-metal and a non-metal. Okay? Metal, non-metal, non-metal. So all we're doing is looking at a periodic table. We're taking things that are on the non-metal side and we're crisscrossing them. So we could go with something like nitrogen and fluorine. Nitrogen is 3 minus, fluorine is 1 minus. You crisscross them, you get NF3. Non-metal, non-metal, so it's covalent. I could have also written molecular. I will take, let's see here, let's do another one. Let's go with sulfur. And how about, let's see, sulfur and selenium. Purposely picked this one. Sulfur is 2 minus. Selenium is also 2 minus. But they're both 2 minuses. They're both from the same vertical column. How do I know which one I put to the left and which one I put to the right? Well, let's look at the periodic table here. Sulfur is here. Selenium is here. You're going to use the one that's above, the topmost one, the one with the least atomic number, however you'd like to think of it. So sulfur is first and then selenium. That's how you're going to do that. And that works the same with our metals. If we happen to have a metallic bond, you would have 2 in the same column. You'd always take the topmost one. So you'll get S2Se2, which we all know already, SSE. And that's going to be non-metal, which would be molecular. There. So we've done ionic and covalent. There you go.